Hey everyone, welcome to Spatial Spotlights. Happy Wednesday. My name is Matt Forrest, and I am the field CTO here at Cardo. And today's event, we are talking about coastal flooding and particularly looking at some different factors that you can use in data sets to actually look at coastal flooding on a much more local scale. So, in today's sort of case study, we'll be looking at coastal flooding in Savannah, Georgia, in the United States. It's a sort of historic community along the coast. And of course, coastal flooding, there's a few different factors you can look at. There's things like historic floodplains and other pieces, but of course, that doesn't always tell you where things are going to flood in the event of things like flash floods or other factors, and especially in low-lying areas. So that's what we're going to look at today. This is particularly applicable for a lot of different industries, but anything from insurance, real estate, if you have any assets like telecommunications assets and things like that, and just about anything that's tied to a place, city planning, all these different factors. So that's what we're going to look at today. We'll talk first a little bit about the data, why there's some complexities using some of these different data sets, and then actually walk through a use case and then end up with a map. So let's go ahead and kick that off. So the first thing I want to look at is actually understanding the flood hazard layers. That's the floodplains in the United States. It's known as the NFHL, provided by FEMA. That's our emergency management service at the national level in the United States. And it's a national flood hazard layer. And this is the viewer that you can use to see that. They have, these layers all around the United States. But they're quite detailed, which is why this map is taking some time to load here. So we're going to keep zooming in to get to Savannah, Georgia, and pop down to see where that is. I guess we can go here and just use the search. And we'll go there. I was pretty close. So if we zoom all the way in, we should start to get some of the actual details to show up on the map. And that's kind of reflective about how detailed this data actually is. You can actually click here and then you'll get sort of a tile or a panel of this data, and you can then download a graphic or get the county data here. So you can see here that these are of course, very detailed. You need to know specifically where things are going to flood. And that's kind of why it takes a long time to load. But it gives you a very clear picture of where these, longer term floodplains are. And then there's these associative codes that go along with that. This is in zone AE. So it kind of tells you that this is the zone here, and then some other data. So it's hard to really make sense of all of this, but like I said, you can kind of download this tile. If you want to download a graphic, it'll let you do that, and then download the county level data. So that graphic will pull up. We'll let that download and see what that looks like. But effectively, these floodplains are really designed for long range flood planning, looking at things into the 100-year floodplains. Now, that makes a lot of sense, but of course the climate is rapidly changing. That's one thing. And then there are also a lot of local factors that you want to consider, such as the infrastructure around that location that may impact coastal flooding or other flood events. So that's what we're going to look at today. There's a few different data sets that we'll pull into this. All the data sets I pulled from the Savannah area GIS Open Data Portal. This is one of them. So this is stormwater manholes, which basically, are, where the stormwater can leave the street and actually go from there. So you can see here that there's a lot in different areas. There's a lot all over, the different locations here, but there's a certain spatial distribution to them. Of course, some are centered around intersections, some have them on the street itself. So, understanding how close you are to one from any specific property, and then of course, how many are in a certain area can maybe tell you how fast something can drain from that. So that's one data set we'll take a look at. And there's a few others I pulled from here as well, including the property parcels, the floodplain data for the entire county, and some other pieces there too. Now, if you want to follow along, this is a modified version of this workflow in the Cardo Academy. If you haven't been to the Cardo Academy, I definitely recommend checking it out. There's a lot of resources here in terms of creating and working with maps and things like that, but also example workflows. So all you have to do is download this workflow and then you can upload that to your Carto account. All the data sets will pull in, and then you can actually play around with this as well. So this one is just a modified version of that. So you can kind of test it out and play around with this after this tutorial. So let's go ahead. Before we do that, let's quickly see what that image brought us from the downloaded floodplain, just so you can see the detail in this data. Let me just open that up here. And I think I have to share to that specific window. So yeah, here's what that floodplain actually looks like in detail for that tile. Like I said, you can kind of download an image of this here, which is great, but of course we want that data, and it's really detailed. So it's now, my preview is stalling out, but you can see these are very detailed geometries, nationwide coverage. It's a really large, kind of difficult data set to work with just because of the number of vertices. Yeah, preview is now asking me to quit. So I think you get the idea of what that looks like. So I'm going to go ahead and get rid of this for now. And we can go back to the tutorial. So let me share my screen back here, and we'll go ahead and get started. So this is the workflow that I put together for this. I'm going to move things out so we can see it, and we'll walk through each step in detail here. So like I said, if you want to follow along, you can modify this. The original one has some geocoding steps to look at geocoding addresses and pulls in just 100 properties. This pulls in all the parcels in Savannah. So my first step was to load in this data for the property parcels in Savannah. To preview that, I can open up this window and go to the map here. And you'll see we have a set of polygons that represent the property parcels in Savannah, Georgia. So this is all the individual property parcels in the city and the county. So this gives us a sense of where buildings may be, or properties you may want to assess, or things like that. So you can see all these different locations. This includes things like parks and different larger buildings and individual homes and houses and stuff like that. So it has a little bit of everything within it. So that's our first step, is to pull that in. And then because these are polygons, I'm just going to create a centroid of all of those so we can use that as a point feature going along. Now from here, there's basically a few different steps that we're going to do. The first is I'm just going to extract the flood zone. So I'm going to do a spatial join to get the flood zone that falls within. Here is that flood zone data that's pulled in from the county. So if you remember back to our original step, you can download that county by county. The county also provides this. But once again, you can see the level of detail here in these geometries. They're very specific because you want to know specifically where things are going to flood. I mean, these are little boundaries around houses, and highly specific, telling us where things are or are not. So lots of detailed information there. The entire county encompasses Savannah, but then all the way out to these sort of coastal islands here, which are in low-lying areas. And of course, there's a different flooding risks as it goes within that, but certainly lots of houses and built environment out in these areas too. So we're going to join that and extract the flood zone. If we look in the data, that's going to be this flood zone here column, and there's a few other details here that tell you a little bit about different depth, velocity, things like that. But this is the column we care about, which is this flood zone, and that correlates to this sheet that basically tells us these different definitions. So there's B, X is basically low risk. Anything with an A is a higher risk. V is a coastal area, and D is undetermined, meaning they don't know. So it'll tell you some of these different things. So there's two definitions for coastal and then general flood risk, which is interesting. So we'll take a look at what that looks like once we pull that in. Okay, so jumping back to the workflow here, this is the stormwater inlets, which is that layer I showed you in the open data portal. If you take a look at that, these are all those stormwater kind of areas where these drains are located throughout the city. Like I said, there's a very clear spatial distribution here. If you're on an inner part of a block, you're not, you generally don't have a storm drain. Sometimes you do, sometimes you don't. Generally clustered around an intersection, but occasionally you see these pop up in the middle of the street. And that, it kind of varies from block to block what that looks like. So it's important to understand that. And we're going to do two things with that. Is we're going to find the distance to the nearest one. So the shorter distance, closer you are, likely the better. And then also the number within a quarter mile. So I'm going to take each parcel, create a quarter mile buffer around it. Half mile here. And you can see that pop up. We should get a bunch of buffer geometries here for every property parcel, which is going to kind of look like a big mess on the screen, but that's what that will be. And then we'll actually count those number of points. From here, I'm going to find the storm head wall, which is basically another feature that is protecting from storm surge and things like that. So there's a variety of these throughout the city protecting different things. As you can see here, there's a sort of a cluster along this highway and road. There's some along some other sort of key areas, inlets and rivers and streams and things like that. So once again, finding proximity to these storm head walls is going to be important to understand what's protected in these different areas. So just for this one, we'll just do the distance to the nearest, and then we'll find the property elevation. So I extracted the elevation data. This is just a smaller subset of data from our data observatory. That's free and open data that you can use with a Carto account. And it's stored in a quad bin. So it's actually stored at quad bin level 18 to show them the data that's here. And then I get my elevation, right? So just my smaller quad bin here. And then I can actually extract a quad bin from that centroid. So I'm going to basically take that point and turn that into a quad bin. And then I can join those without using a spatial join. I can just join those on the quad bin itself. So I'm just using that numeric column to do that, which is a little bit more efficient in this case, especially when you're dealing with, 150,000 records or something like that. So those are the steps. And then from here, there's a lot of data cleaning, basically. So I end up with my layer of my flood zones, my nearest drain, drains within a half mile, the head walls and the elevation. And in each of these steps, they're pretty repetitive, but I'm going to join those two data sets and I'm going to get rid of unnecessary columns. So I perform the join here on that object ID, which is the parcel ID. And then I drop columns that I don't need. In this case, this object ID joined. I don't need that in the next step. I just need one object ID. I don't need it getting confused. So that is what this step does. I join, drop it, join, drop it, join, drop it all the way down. And then what I'm going to end up with is a centroid data set here that has all of those different extra columns that I care about. So I'm going to get all of those columns. And then my goal is to end up with one final risk score. Now, when we look at risk scoring, index scoring, anything like that, you have to account for the spread of the values. So let's take the distance to the nearest head wall. That could be a meter away from the property centroid. It could be 10 meters away. It could be 100 meters away. It could be, 5 kilometers away. We don't know how far that is. So your range could be from 1 to into the thousands, right? And then consider the count within there, within a quarter mile, you may be looking at, let's say 1 to 20, just as an example. So those two numbers are very far off. And if you're trying to, get that in terms of a scale or a score, you need to normalize that data. And that's exactly what this component does, is it will normalize it on a scale from 0 to 1. So basically, for each element, I can scale that. And now I have this single sort of integer, 1 being the highest, 0 being the lowest, that's scaled appropriately for that data scale. So what that allows me to do is I can do that for each different column here. This is going to be for the nearest inlet. This is for the number of inlets within a half mile. This is for the nearest head wall. This is for the elevation. And then what I'm going to do is basically add all of those together and create one final risk score. And then I save that out as a table. So that's the entire workflow here. It can go ahead and then you go ahead and hit run. That will run the entire process through for every single property. And then we can actually take a look at what the output map is and see some of those interesting results. What we can do here now is go into our maps, and I have a wonderful map pre-prepared for this, of course. And that is in this coastal risk score here. So this will load up and this will tell us a few different things. So what I want to look at here is we'll zoom all the way out. Now the map is styled based on that risk score. So the darker areas here are the lower risk. The lighter areas are where there are higher risk. So you can see there's a very clear spatial distribution. Obviously, as we move closer to the coast, that makes sense. There's a higher risk, but then also in this downtown area, there's, this central city, there's a risk. And then over here in these other areas looking like Bloomingdale and sort of through this strip of area here. So that tells us something interesting. And we can kind of start to see what those look like as we filter them. So we can also look at that from an elevation perspective. So just in the low-lying areas, this is elevation meters above sea level. So you can see where these very low lying areas are. There's also, it's interesting that there's some, sort of strong protections in these areas as we move over here. This is probably representative of proximity to a storm drain or things like that, but they're certainly in a low lying area. And then you can see the comparison to the flood zone here. This is where I think things start to get interesting, is when you compare this to the flood zones. If we go back to our reference table, you can see that AE right here. This is where the base flood elevations are provided. They're sort of called the A1 through 30 zones. And this kind of gives you some information about these. There's different metrics here about the 1% flood risk and things like that. So there's different specific numbers within those that we could also look at. So that's interesting. What tells us, there's these lower risk areas that may be in a flood zone and some that are also not in a flood zone. So let's go ahead and look over here. So we see this one that's VE, that's that coastal flood that we want to take a look at. VE is right here. So you can also see here, these are these coastal flood risks. If we jump back to our document, these have a 1% or greater chance of flooding, an additional hazard with strong waves. These areas have a 26% chance of flooding over the life of a 30-year mortgage. Base elevations are derived from blah, blah, blah. So what I think is interesting, whereas, first of all, you can see where the coastal areas are, but there's also high risk areas and low risk areas that are based off of, things like proximity to that specific environment. And we can see that specifically if we want to add a click window here. So I'll just add a click window. We'll add the object IDs. That's our property ID. And what we'll do is let's get the elevation. We'll get the actual flood zone so you can see that. That's the number of different features, nearest inlet distance, nearest head wall. And then I think there's also, that's the normalized, we'll get the actual risk score. And then there's this total assessment value in each property. So we can actually go in here and see. So if we want to look at these higher risk zones kind of clustered over here, we can go ahead and click on any of these properties. So we can see here that's in that zone flood VE. And you can see there's no sort of, there's no storm inlets closest to that. You can see that the nearest one is, 4 miles away, I think. Is that what that's saying? And then the nearest head wall is, 5 miles away, something like that. So they're not close, and this represents a moderate score. And then the actual assessment of that property value. Some are assessed, some are not. So as you see here, you can kind of go understand, obviously low-lying elevation, nearest inlet, nearest head wall, things like that. And you can add those map layers back in to get more detail there, but, it gives you a sense of what these things are and the properties and parcels like that. So what's really interesting to me is when you look at these very specific flood zones. If I want to look at AE, that's that flood assessment risk. You get these areas that are, have some of those different protections built into them, like proximity to some of those drainages. So you can see this is a moderate elevation, but it is in a flood zone. You can see it's close to a river here, but close to inlets and head walls. So that gives that some of that extra protection since it's close to that. Whereas a property over here, if we clear that out, that's in that Z area, still in X, which means that it's not in a specific flood zone. It's, just sort of not defined specifically here. And so switch back to the map so you can get a sense of what those look like. And I think that's very interesting. So this is just looking at elevation, but we can also look at, risk as just a total metric of risk. So we'll go to the higher end of the risk scores, go into the scores of 1 or 1-ish or greater. And then that gives you that very clear picture where there's areas or clusters of risk, right? Right over here along the inlet, you can see some of these are, in fact, homes and properties. Some of these are, different just parcels of land and things like that. But I think it's very interesting that tells you very specifically where those are, and it's related somewhat to that built environment that we can start to add in. But very clear that there's a relative risk here in this, downtown area. There's flooding, even though most of these things are not, in fact, in a flood zone. So that kind of tells you something else here is what those look like. Now, there's a lot more steps you can do to this. The first step would be to add more data in. If you have different data on the properties themselves, maybe some more detail on flood zones, if you have some information on flash flooding or anything like that, can give you a better indication of what's happening there. On top of that, you can also layer in some details around the properties themselves, and there's probably other open data out there that you can explore. And then obviously layering in some visual information here can also help. It's fairly easy to add some data here. If you want to add those in, we can bring those layers in. If you do choose to do that, you can go here into that workflow that you downloaded. So if we wanted to grab those inlets, over here I click on that, you can see there's a link here. I can just go ahead and copy that link and then bring that into the map here, so I can import a file, do that from a link. And if you want to build this out yourself, there's a great way to kind of take this forward and continue to explore and play around with this. So that's kind of what I suggest as next steps, is to keep playing around with this and exploring some different layers, and take that forward. But this is a pretty common place type of thing right now, is to try to understand those broader risks outside of what's just sort of given to you, especially if you want to get detailed information of, if you're looking at properties, if you're in a municipality, where do you want to expand? And then most importantly, insurance and risk, to understanding what that looks like. So that's sort of the details here in terms of what you can do. There's a lot you can take forward. So I think plenty to do there. That's kind of the demo for today. If you have any questions, don't hesitate to reach out. Since you're watching this on LinkedIn, you can find my profile and send me any questions you have. And then happy to kind of answer those as they come in. But thank you today for joining us and spending some time learning about coastal flood risk with Cardo. Yeah, thank you.